Let's take a look at a textbook problem related to KP and ice charts as well. So this problem is from your textbook. It says at 1,000 Kelvin, a sample of pure NO2 gas decomposes. The equilibrium constant Kp is 158. Analysis shows that the partial pressure of O2 is 0.25 atm at equilibrium. We're going to find the other pressures at equilibrium. So I am told that we have a pure amount that's put in. So this implies an initial value. If I have initial and I have equilibrium, this is a situation where I want to use an ice chart. So I'm going to start by writing the reaction so that I can fill stuff in under it. 2NO2 is an equilibrium with 2NO plus O2. Now, here's the thing. I don't know how much NO2 I started with, but I know I started only with NO2, which means these must have been 0 to begin with. I don't know what the NO2 value is, but I know it's going to decrease by an amount of 2x to some final value. 2NO will increase by 2x. O2 will increase by x. We are told that at equilibrium, the O2 is 0.25. Now I can clearly figure out what x is. 0 plus x equals 0.25, x equals 0.25, meaning the NO2 at equilibrium would be 0.5. I still don't know the NO2, but I have part of my answer to this problem done. To do the rest of the problem, I need to work with the Kp value. So I'm going to write a Kp expression. Kp equals the partial pressure of NO squared over the pressure of O2 over the pressure of NO2 squared. The Kp value is given to me as 158. I know NO is 0.5 at equilibrium. O2 is 0.25, which means I can solve for the partial pressure of NO2 at equilibrium. Realize I'm going to need a calculator to solve this problem. So I'm going to do 0.5 squared times 0.25 divided by 158, and then I need to square root my answer, and we get PNO2 equals 0.0329, or 0.033 if I'm paying attention to sig figs, and my units are ATM. That comprises one part of my answer, and this comprises the other part of my answer.